Bismillahirrahmanirrahim. We will be starting module number 2. Module number 2 of the course Information System Security MIS470 is basically about the encryption system of information security. In module number 2, we talk about the general introduction about the information system security. Module 2 is mostly about the cryptography schemes. Before starting the module number 2, I would like to clarify you that there are basically two encryption system in the world. The one is called the symmetric and another is called asymmetric. In the symmetric, we use only one key, okay, and while in asymmetric we need two keys, one for opening and one for closing, and vice versa. Okay, we will properly and just like a start. Okay, that is concept of encryption. What are the concept of encryption? We will see the cryptanalysis, that how encryption system can be broken. Means cryptanalysis is the opposite of encryption. Means it is just like the crack or the break of the encryption. Okay, so the symmetric key, this is called secret key. You just need a one key only for encryption and decryption. Okay, so you don't need the other two keys for that one. And the example for the symmetrics are DES, DES algorithm, and AES advanced algorithm, and DES algorithm. For asymmetric, which is called public key, in the public key you need two keys. One is called public key, which is available to all the people, and it is used for encryption. And another is a private key, which is only for with the person to whom the message is for. Okay, so the asymmetric key, public key encryption, and the example for this asymmetric is RSA. Okay, RSA is the name of three mathematicians or scientists who invented this algorithm. Then we have a key exchange protocols and certificates. That what are the different exchange protocols and certificates. We will discuss about the digital signature as well, and cryptographic hash functions. Okay, so these are the different things which we're going to discuss in module number 2. So what is the concept of encryption? Cryptography is rooted in higher mathematics. So cryptography can be considered as a branch of mathematics as well. So we need group or field theory as well. We need computational complexity. The more complex an algorithm is, the more strong it will be. For example, they say that question of extent to which a problem is solvable on a computer. So the more time it takes to for a computer to solve it, the strongest is the algorithm. Okay. The next one is the real analysis, the theory of function of real variables, in addition to the probability and statistics. So the quantum cryptography can be used in the probability and statistics way as well. Concept of encryption. In this one, you need to consider steps involved in sending messages from sender S. So let's suppose if there is a sender, so you name it as a S, okay, and the receiver as a R, okay, or the recipient as a R. Okay, so if S entrusts the message to T, okay, if the sender he wants the message to send to the R, okay, and the message is T, then becomes a transmission medium. Okay, so T is considered to be the transmission medium. If an outsider let's suppose O is an outsider, wants to access the message, even he wants to read your message, or he wants to change your message, or even he want to destroy it, we call O as an interceptor or intruder. So O is a bad guy. Okay, so O is a bad guy, S is your sender, and R is your receiver, and T is your transmission medium. Okay, so O, the bad guy, might try to access the message in any of the following ways. For example, it can block it, it can intercept it, it can modify it, and it can fabricate it. So as we discussed in module number 2, that there are different ways how the software or how the hardware or how the data can be modified. So there are attacked or modified or just like hacked. Okay, so we say that the person, the bad guy, or outsider, okay, it can block it by preventing its reaching R before it reaches to the receiver or the recipient, therefore affecting the availability of the message. So it can block that. Intercept means by reading or listening to the message, thereby affecting the confidentiality of the message, although the message will be received by the recipient R, but he will listen it and he will read it, the message as well. Okay, In modify, what it will do, the message, the R will receive the message, but it will be modified and it will be changed by seizing the message and changing it to some way affecting the message integrity. Fabricate an authentic looking message. In fabricate, he will, the person, the recipient, he will see that the message is authenticated, but although it is fabricated. Authentic looking message, it will look like this, that is, it is the most authentic and it is the okay message, but in fact there is some change. So arranging for it to be delivered as if it is came from us, thereby also affecting the integrity of the message. So the modify and the fabricate, there is a little bit difference. In modify you can see that there is some effects of the there is a change in the message, but in fabricate you don't feel the change. The change is so delicate that it is not distinguishable. A message vulnerability reflects the 4 possible security failures we identified earlier. So this was all about the different things that what the outsider can do with it. Now we have some terminologies which will be important for you, for my students, and for the international audience as well. You can see here encryption. What is encryption? If someone asks you that, what do you mean by encryption? So you can easily tell him or her that encryption is a process of encoding a message so that its meaning is not obvious. For example, if you say that attack, for example, attack on a country, or for example, this is a secret message. Okay, so the same message, the same sentence, it will be in such a way that it will not be understandable by other people, but it will be only understandable by the recipient only. The sender and the recipient can understand this the message, but the outsider will not be able to understand it. Decryption is a reverse process, transforming an encrypted message back into its normal original form. Okay, for example, the sender will encrypt and the recipient will decrypt it. So these two processes are on different ends. Alternatively, the terms encode and decode or encipher, decipher are used instead of encrypt and decrypt. So you can use the alternative words encode and decode. Encoding and decoding is most usually used in a communication, in a telecom communication, okay, for encoding the different bits. Okay, but you can use for the encryption decryption as well. Yeah, the encipher and decipher, this is very common, okay, in information security paradigms. We say that we encode, encrypt, and encipher the original message to hide its meaning. Yeah, that's it. Okay, that's meant to hide its meaning so that the other people cannot understand it. The confidentiality, integrity remains constant. We decode and we decrypt or decipher it to reveal the original message. Yes, that's obvious. Okay, a system for encryption decryption is called cryptosystem. A cryptosystem is the equation. Crypto system is an algorithm. A crypto system is a process. Okay, so it is a system for encryption and decryption. So it can be just like a simple equation like C equal to PT. Okay, C equal to ciphertext equal to plain text multiplied by the plain text into the key pk, sorry, not the pt, the pk. C equal to p multiplied by k. So k is the key, p is the plain text, and c is the ciphertext. So that can be a simple equation, or it can be a complex algorithm consisting of many lines. Okay, or it can be a process. Okay, it can be a process by shifting one data into another form. Okay, so various kind of crypto system exists over here. We will discuss in more detail. Slight difference, not significant in this course. Okay, encoding is the process of translating entire words or phrase to other words or phrase. Okay, enciphering is translating the letter or symbol individually. Okay, so I told you that there is a little bit difference in these two. Okay, while encryption is a group term that covers both encoding and enciphering. So there is a difference between encoding and enciphering. Okay, encryption is a comprehensive word. Encryption is a more comprehensive word which covers both encoding and enciphering. So what is the encoding? So it is a process for translate the entire word. The entire word is transferred, or the phrase is being transferred to other words or phrase. Okay, while enciphering is translated letter by letter or symbol by symbol. Okay, encoding is word by word, and enciphering is by letter or symbol by symbol, while encryption is used for both. Okay, so what is the method? You can see over here, you can see over here there is a like a plain text over here. This is a plain text. Okay, this box tell you a system. Okay, this is a part of the system. You just feed the system with the plain text. Encryption is done over here. Okay, and this is the ciphertext. Now this is encrypted now. Okay, the outsider will attack over here if so. Okay, so this is the ciphertext. Here this is the recipient, this is the sender, and this is the recipient. So the recipient will receive your ciphertext and it will decrypt it with a key, okay, and then you will get an original plain text. So this is a very simple phenomena, and this phenomena will be more complex with the passage of time when we will have some strong algorithm like DES, AES, RSA. The original form of message is known as a plain text. The encrypted form is called ciphertext. This is very clear now, I think. We denote a plain text P as a sequence of individual characters P1, P2 as a Pn. Okay, so there can be different kind of messages, plain text. Okay, P1, P2, P3, P up to Pn. Okay, similarly, the ciphertext can be termed as C. So you can choose any alphabet, but the convention is like C. Okay. P and C. So C can be like C1, C2. So you can have many messages. So you can name the first message as a C1, the second message is C2, another one C3, and up to CM. So CM is the last message you have. Example. Now we have some example like the plain text. We have the message I want cookies. Okay, this is a message and you want to encrypt it. So how you gonna do that one? It can be denoted as a message string like I want cookies. So I is another word. Okay, as we told that in encryption or enciphering is by letter, okay, or word by word. No, not word by word, it's a letter by letter or by symbol by symbol. So we differentiate each and every letter. The first I is a one letter. Okay, there is a space, so space is also considered as a letter. W is considered as a letter, A is considered as a letter, N is considered as a letter, T is considered as a letter, and then we have space. And similarly for the cookies as well. Okay, so it can be transformed into the ciphertext like C1, C2, C3, C14. Okay, how many words we have? If you just count it down, okay, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so these are 14 with along with the two spaces. Okay, so 12 are the letters, 12 letters with the two spaces. Okay, so we will be having total C14. Okay, so C1 is now considered I is a C1, C2 is a space, W is a C3, and the last one is C14 is S, cookies S. Okay, the last letter. And the encryption algorithm tell us how the transformation is done. Okay, so as I told you in the previous slide that you will have the plain text will go in this box. Okay, this rectangular box. After being processed from the encryption, it will go to the ciphertext, and from the ciphertext it will be the decryption will be done over it, and then you will have an original plain text. Okay, so that is all story about the encryption and decryption. So it seems very interesting. You will enjoy after by having some of the practices, some of the words you have. I can give you some words for the practice, so that will be more interesting if you practice over it. Okay, and you will enjoy it, I hope. Okay, as time is running out, so usually my lecture is about maximum to 15 minutes, so I would just wind it up. Okay, and then we can start the more terminology in my lecture number 2. Okay, so this module will have more maybe 5 to 7 lectures, because this module number 2 is a bit long. It's about 124 slides. Okay, so I'm gonna make it easy these slides by giving you some more example, and by giving you some practice as well. Okay, so I hope that you will enjoy this module 2. Module 2 is very important for my students, and as well as those international students who are doing research on the cryptography specifically. Okay, so though if you find any difficulties, you can send me comments on my YouTube as well. Okay, or send me email by provided in the first slide. Okay, or you can call me. Okay, thank you very much, so nice of you, and stay tuned with us for lecture number 2.